I'm also very happy with the venue we're in. I think it's really special. And the story of this venue very nicely connects about the issues we're talking about, because this came out of a protest. Google announced in 2015 to launch a startup campus at this location. And after the announcement, there were protests of the local population linking this all to the issue of gentrification and even occupying the space in 2018 briefly. The result of it that they managed to get this free of rent for 5 years and creating this wonderful space we are in here. But the agreement runs out at the end of this year. So in December 2026, it might be over. That's why you can see everywhere that they're campaigning for a continuation. And I would just like to ask you to support this cause, because we need places like this in Berlin. Okay, that was the brief intro to our discussion about big tech and power and all of that. And I'm really very happy to introduce Nick Srnicek, who is a lecturer in digital economy at the Department of Digital Humanities at King's College in London. And Nick is one of the leading voices, I would say, in debates about digital capitalism. His 2017 book, Platform Capitalism, was an eye-opener for many, including me, because it provided a very early critical account of platform business models in contemporary capitalism, how they operate, how they thrive on exploiting data, and how they skim off revenues from economic processes elsewhere. This account proved to be very influential. Since then, he also enriched debate on many other topics, among other his book with Helen Hester, After Work, on the relationship between technological change and care work. But most importantly, he has been observing the shifts in big tech and platform business models continuously. And there has been a lot of changes since the age of social media platforms and so on. So things are different now. And the relevance of his new book, Silicon Empires, is to provide an account of precisely that. What is different in capital accumulation around new technologies in the age of generative AI in comparison to the period where big tech mainly thrived on user data of social media and communication. So Nick now will speak about 40 minutes. Then we will merge this into a panel discussion with the title AI, Power Concentration and Politics, Has Big Tech Taken Over? That Esther will chair after this keynote. Thank you, Nick. The floor is yours.
Okay. Thank you for those kind words, and thank you, everybody, for coming to this talk. Apologies for being a little bit late. I was delayed by my flight, but it's lovely to be here. I'm going to be talking about what I call Silicon Empires. So this is the big AI companies, but also their sort of interrelations with the great powers, particularly the US and China. Now, this talk builds off of my book, and it's going to cover a lot of the stuff that I talk about in my book. But one of the sort of enjoyable aspects of this field is that it's constantly moving. So my book was finished in, I think, April of 2025, which is an eternity in the AI world. So I'm going to talk about some things which are sort of updated and try and bring it up to speed. Now, one of the key things I try and talk about in the book is this issue of value. So literally trillions of dollars being thrown around within the AI industry. And the question of where all that money is going, where it's going to end up, is one of the big open questions at the moment. And one of the easiest ways to sort of frame this question and think about it is to use this model of the stack. So the idea of the different layers of AI tools and infrastructures that are necessary to make something like ChatGPT work in the first place. So at the top level, we have apps, which is what probably all of us have experienced. When you open up ChatGPT, you are opening up an app. Now, there's a lot of competition here, precisely because there hasn't really been a killer app found yet. And something like Claude Code might be a killer app. We're still sort of figuring that out. But there's lots of competition here to try and figure out how do we present these models to users. Now, if we move down the stack, we get to the model layer. And this is where there's a lot of attention paid to it. And I'm particularly interested in these transformer-based neural networks. So transformer is the name of the architecture behind ChatGPT, Claude, behind Gemini. All of the sort of generative AI stuff that we talk about is usually transformer or some sort of variant of the transformer architecture. Now here, I think we have a surprising amount of competition. Because one thing that if you know nothing else about AI, one thing you probably know is that it costs a lot of money to make a model. So you would expect with these high costs that we wouldn't actually have a lot of people sort of making models. But that's not what we find. We actually find that there are a lot of models being made, and not just by a handful of companies, but actually by quite a few different organizations. Now, I will note that in this diagram here, 2024, you can see it sort of tapering off, and I imagine in 2025, it continued to taper off. My theory is that in 2023, you had a bunch of American AI startups who decided that when they wanted to go and find money from investors, they trained a little model to prove that they were an AI company. So it was sort of a symbolic gesture rather than something that was meant to be economically useful. Now, moving down the stack, we get to the infrastructure layer. This is the layer of data centers. Obviously a massive topic in many, many countries at the moment, particularly in America. I know in Berlin it's an issue. I was in Amsterdam a couple of days ago. It's a massive issue there as well. So here you've got accelerator chips, mostly GPUs. You've got hundreds of thousands of these things being tied together, upwards of 1 million nowadays. You've got these incredible networking components that are linking them all together, making them work as a coherent system. You've got huge amounts of energy necessary to run all of this stuff, gigawatt scale. And you've got huge buildings to encompass all of it. So I think Meta's Hyperion data center that they're building is among the largest buildings ever made in the world. And along with that, you need the real estate to put it all on. Now, there's a theme going on here, which is that as we move down the stack, we see less and less competition. And at the infrastructure layer, it's really just 3 companies. It's Amazon, it's Google, and it's Microsoft. Alibaba and Huawei are sort of players within the Chinese space, but they don't have much of a global footprint yet. Then we get to the final layer of hardware. So the actual accelerator chips themselves, the GPUs or the TPUs or the application-specific integrated circuits. And increasingly important is high bandwidth memory. So if you are a video gamer or if you want to go and buy a new computer this year, you're shit out of luck because things are really expensive now. Memory is going to the AI companies, and memory prices are skyrocketing. So personal computers, smartphones this year are all going to see a massive increase in prices. At this layer, it's one company, really. It's Jensen Huang and NVIDIA dominating the market. Bloomberg estimates that they control around 90% of the market for training chips, which is where most of the money is headed towards. And then most of the research is being done on NVIDIA chips as well. We can see that they are the early winner in terms of where value is flowing by looking at charts like this. So they were not a small company before ChatGPT came along, and they were quite a successful video game company. But as soon as ChatGPT was released, their market valuation absolutely skyrocketed. And it's almost touched $6 trillion, which just continues to blow my mind. A $6 trillion company. The question is, though, if we look at other periods of massive technological transformation, the early winners are not necessarily always the winners in the medium term or the long term. I mean, AOL and Yahoo as examples of sort of internet companies that led the way and then just disappeared. And NVIDIA is facing some major headwinds here. So Google, Microsoft, and Amazon are all developing their own NVIDIA alternatives. They don't want to be dependent on one supplier. Google's TPUs have been around for about 10 years now, and they're quite successful. Amazon's Trainium chips and other chips are doing really well. And then you've got the Chinese market. So Huawei, Alibaba, and Baidu are all creating their own alternatives that are catching up. And the Chinese government is increasingly saying to its companies and its state-owned enterprises, do not buy NVIDIA chips. Do not become dependent on America. So if you want to buy NVIDIA chips and you're a Chinese company right now, you have to go to the government and explain why it's necessary. So all of this means that the massive valuation for NVIDIA at the moment may have reached a peak. And that's not investment advice. But there are major headwinds in terms of continuing to dominate the market. So the question then becomes, where is all of this value going to go in the medium to long term? Now, I like to think about generative AI as what's called a general purpose technology in economics. And in the economics literature, there's three sort of characteristics that go with this idea. GPTs are broadly applicable across an economy, so they don't just work in one business or one industry. Instead, they can be taken up by every industry. They also require what are called complementary innovations in different areas. So imagine the steam engine, for instance. We invent the steam engine, but applying it to a locomotive is very different from applying it to a factory. And each of those sort of use cases requires a series of adaptations and their own innovations to make these things work. The third characteristic is that these things have a capacity for significant internal development. So they continue to get better and better. We see this with AI. We can also think about the steam engine. You know, we didn't just build it and leave it there. Instead, we made it more powerful. We made it smaller. We made it more efficient. All of these sorts of things going on. The end result is that you get something like a virtuous cycle of GPTs. So you can imagine in this top right-hand side, a handful of companies might adopt this new technology. As they adopt it, they have to add some innovations to make it work in their fields. Those innovations get rolled back into that core technology. They also provide more money to innovate on that core technology. And as that core technology gets better, more companies start to adopt it, until everybody in the economy has effectively adopted this thing. GPTs end up producing a lot of productivity growth and a lot of economic growth. And as we'll get to later, also massive social and political change as well. Now, really crucial to the story that I try and tell in my book, and what I think is a useful framework for thinking about all of this stuff, is this distinction between that general technology and the specific applications made of it. So this is a diagram here that comes from the original economics formalization of GPTs, and you can sort of get a sense of what I mean here. Now, this division is really important because it leads to a few key challenges for the big AI companies. The first challenge is diffusion. And this is basically the fact that if you are a company that has produced a general purpose technology like OpenAI, you're very good at building LLMs, but you don't necessarily know anything about education or healthcare or legal services. You are dependent on other companies taking up this technology, adopting it, putting those complementary innovations into it. And this is not just a problem with AI, it's a problem with every general purpose technology. So there's a long history of this sort of thing. There's a great paper from Paul David that I recommend everyone read, which is about the electrification of factories. And he looks at why it took so long for electricity to diffuse into factories. Because people knew electricity was going to be transformative, but it still took, as he shows, 4 decades for this stuff to get fully rolled out and the sort of full productivity benefits and everything to come about. A similar thing seems quite likely to happen with AI today. And we can sort of see that process happening as we look out. Lots of news stories about, are businesses adopting this technology? Are they not? And I think the sort of timescale that we're looking at right now is maybe a bit too short. It may be 5 years, 10 years, that sort of thing. One really interesting thing that's happened since I wrote the book is the rise of this position called a forward deployed engineer. Now, this is a position that was pioneered by Palantir, boo, but then it was picked up by OpenAI, it was picked up by Anthropic, and it was picked up by Google. And basically what this role does is people will go and work closely with a customer on site to figure out how to use this technology, adapt it, and adopt it into their particular circumstances. So this picture here is an OpenAI FDE working with John Deere. And in this case, what happened is that they found that the voice recognition stuff wasn't working well enough for John Deere. So they fixed that for John Deere, and then they rolled that innovation back into the core technology. So you get this sort of virtuous cycle of GPTs going on. And this is a recognition by the companies that this challenge of diffusion is central to their business. The second challenge, though, and I think it's the all-important one for them, is the issue of value capture. Because you can imagine a circumstance where they've solved diffusion, everybody's now using their technology, but the money's going elsewhere. It's going to NVIDIA, it's going to Google, it's going to some healthcare company that's created a fantastic cancer-fixing app or something. Historically, this is what happens. Looking at the historical cases of GPTs, the money goes elsewhere. It goes to downstream users, it goes to consumers, it doesn't go to the companies that actually make this technology. And it ends up that one of the major themes of the economics work on GPTs is that because so little money comes back to these companies, government should step in to provide the incentives to build this technology. That's a recurring theme throughout this stuff. And it may be the case that actually OpenAI, Anthropic don't end up making a lot of money. And that would just follow this sort of historical pattern. Now, in response to these two challenges, I think the companies have tried to come up with a variety of strategies, consciously or unconsciously, to try and capture as much value from this stuff as possible, and to solve that diffusion issue at the same time. So the infrastructure strategy is embodied by Amazon, Microsoft, Alibaba, and the core idea here is to maximize the usage of any AI model whatsoever. Doesn't matter which one it is, just as long as people are using AI and they're using it on your infrastructure. The idea here is that you'll then capture a little bit of value from every single use of AI, and as people use loads and loads of AI, that means loads and loads of money for your company. Now, there's a few sort of behaviors that then emerge from this strategy. One is to try and get as many models and AI startups onto your platform, and another is to try and get as many customers onto your platform as well by, for instance, offering free training programs. They're not doing this out of the goodness of their heart. They're doing it simply so that small businesses and all these other organizations can use this technology and then pay Amazon money. I'll give one example of this sort of strategy in practice, which is AWS's Generative AI Accelerator. And the idea here is that this is a series of incentives to get AI startups to build their business on AWS. And you can get upwards to $1 million in cloud credits, which is not too shabby. Lots of sort of benefits as long as you're building it on their particular infrastructure. The second key strategy is, I think, the most publicly visible one, because this is where lots of the money is sort of circulating around. It's what I call a frontier strategy in the book, but I've increasingly started to think that it's maybe more of a hub strategy or even a platform strategy. The idea fundamentally is to maximize the usage of a specific AI model. And it doesn't matter what platform it runs on or what infrastructure, as long as people are using your model. Ultimately, the idea is to become the hub of an ecosystem where you can capture value. So think about the way in which Apple, for instance, dominates its ecosystem, all the developers that are dependent upon it, the massive cut that Apple takes through the App Store, the huge supply chain, which is controlled by Apple. All of that is a way to capture value through power. Now, the frontier strategy is fundamentally focused on trying to compete over capabilities, which is why there's such a rush to get the next best model out. But competition is quite high, and it's really easy for users to move to a new model. Claude's got their new model out, so everybody moves to Claude. OpenAI will be out with a new model in like a couple weeks. Everybody might move to OpenAI. It's really easy, and there's very little lock-in at the moment. So increasingly, the aim is to become a closed ecosystem, to lock users into a particular model. And there's a variety of ways in which they're starting to do this, but I'll give one sort of technical example here. So this is OpenAI's Apps SDK, their software development kit. And this is responding to the question of how do you integrate an AI model with a third-party service like Spotify or Uber or something like that. And Apps SDK answers that by saying that these third-party services can write code to have their services appear within the ChatGPT interface. But it does so in a closed way. So if you write that code for ChatGPT, it doesn't work for Anthropic, it doesn't work for Gemini, it doesn't work for any open source model. And that is an example of trying to build a closed ecosystem. There are alternatives. You could have had ChatGPT in the apps itself, or they could have relied upon an open protocol, something like MCP apps, as a way to keep this more open. But they want to build a closed ecosystem. I'll give another example, which is there's a massive uproar on Twitter today about the new Claude model because it prevents people from doing any sort of AI machine learning research with this model. And it does so in a sort of a sneaky way, because it doesn't tell you that it's not going to give you the answer. Instead, it tries to navigate away from giving you a proper answer. And so this is a way of like maintaining the information that's embedded within this model within Anthropic. Nobody else, including open source users, can get access to this sort of thing anymore. So again, a closing of the ecosystem which is happening. The conglomerate strategy is the third one. Politically, I think it's the most terrifying, but as an intellectual, I find it the most interesting. It's so terrifying because it means a massive expansion of the power of these companies. And there's really only two companies doing it at the moment. It's Google and Huawei, because it requires a huge amount of resources to do it. And here the idea is that you're not just going to build that general model, you're actually going to go downstream and start building more specific applications. The most visible expression of this is something like Google's massive amount of models which are very task-specific. So they've got drug discovery models, they've got personal fitness models, education models, chemistry models, mathematics models. They don't just have Gemini. So each of these is an attempt to weave their way into these downstream applications and capture value in a very direct way. Another really interesting example from Huawei is they have a Pangu mine model, which is just designed to be used in the mining industry. So again, lots of different ways in which this stuff is trying to reach into these particular sectors. The last strategy is the open strategy. And when I wrote my book, Meta was the major example of it. But Meta sort of turned away from open source. Alibaba was a big supporter of open source last year, but they seem to be turning away from it. And DeepSeek may be the last sort of major standing figure of the open approach. The idea in this approach is that you train a model, and you spend loads of money doing that, and then you give the parameters, the weights away for free. So people can use your model and play with it. And then the idea is that everybody will start innovating with your model. They'll make it more efficient. They'll add new features to it. They'll expand context windows and things like that. And by doing so, you can then take that freely produced innovation and roll it back into your core model. You're effectively capturing all of this free, decentralized innovation. A number of different things involved in this strategy. A key one, I think, is fostering a relationship with the open source community. It's a much different community than just a simple business. And so there's been a lot of efforts by Alibaba and by Meta to try and foster that sort of relationship. Here's a summary of all these things. I'm not going to go through this slide, but if you want to take a picture and have a summary of it all, here's a nice chance. One thing I think is useful about distinguishing these different strategies is that you start to realize that, yes, these companies are all competing with each other, but they're doing so in very different ways, and they also have different reactions to events that happen in the AI industry. So there are, for instance, different tensions between these strategies, and there's different failure modes for these strategies. And again, I'm not going to go through this slide. I go through it more in my book, but I'll give one example which illustrates this. When DeepSeek released their R1 model in January of 2025, the stock markets in the US plunged. NVIDIA lost over $500 billion because it seemed to suggest that here was a really capable frontier model that didn't require a lot of money to train it. So that was really terrible for the frontier companies. If somebody was doing what they were doing, but doing so an order of magnitude or two less money. However, at the same time, Satya Nadella, CEO of Microsoft, came out and said, he was asked about DeepSeek, and he says, DeepSeek was fantastic. He loved it. And why would he say that? Well, he's focused on the infrastructure strategy. Open source models, cheap models, mean more people are going to use this infrastructure. So for him, DeepSeek was great. For OpenAI, his close partner, it was terrible. And you can only understand these sort of differing reactions by understanding the different strategies involved here. All of that being said, that is the capitalist side of things. That is what these companies are doing in the pursuit of profit. But of course, it's not just about the pursuit of profit anymore. It's also about the pursuit of power. And historically speaking, general purpose technologies have played a really big role in transformations of the international balance of power. So it's not really any surprise to see every great power today and every wannabe great power focused on AI as a massive new technology. They want to secure their place in the 21st century, effectively. There's a really great book on this, which I highly recommend, Jeffrey Ding's book, Technology and the Rise of Great Powers. And in that book, he sets out two different theories to try and understand why general purpose technologies have a massive impact on the balance of power internationally. The traditional theory he sets out is leading sector theory, or innovation theory, which basically argues that a country has these innovators in a technology, they capture monopoly profits, that boosts the economy, boosts the military, and then boosts your international standing. Jeffrey Ding says that's wrong. Instead, he presents this diffusion theory. And diffusion theory says what's important is not who's innovating in that technology, but who's adopting it, who's diffusing this technology the most. So widespread adoption boosts the economy, boosts the military, and then boosts your international standing. Now, Ding's book is an argument for that second theory there, but I think this distinction between an innovation approach and a diffusion approach very nicely gets to the distinction between America's approach to AI and China's approach to AI. So America, very simply put, has an innovation strategy. They are, in the lingo of the space, of the AI space, they are AGI-pilled. They are trying to advance the AI frontier as quickly as possible, fueled almost entirely by private investment as opposed to China, and is fostering this deregulatory agenda domestically, particularly around energy, so trying to speed up energy permitting, nuclear energy processes, things like that, but also this repeated effort to try and block states from passing any sort of AI regulation whatsoever, which has thankfully failed so far, but I think we will see it recurring again and again. There's also, at least under the Trump administration, been a minimization of AI safety concerns, and there's been a real kick against any international governance as well. Any sort of industrial policies that America has are market-led. They're basically giving backstops and money to these companies and saying, go and do what you want, as opposed to a sort of government-driven approach. China, by contrast, is much more focused on diffusion. So figuring out how to get these tools spread throughout the economy and adopted by everybody. This goes back to 2017 as well, so it predates ChatGPT. There was a next generation AI development plan released in 2017. It's all about how do you diffuse this technology. Giving government support for pilot projects, local experiments with AI, and giving support to small businesses to try and use this technology. All of this is about getting this technology out there. I think one quite striking visual difference between these two strategies comes in their approach to this question of how do we build large amounts of compute? And in the US, it's focused around things like the Stargate initiative, which is oriented towards building huge compute clusters, multi-gigawatt scale compute clusters that are designed effectively for one single company, usually OpenAI, and they're aimed at training one grand model, GPT-8 or something like that. By contrast, China's response to building out compute has been what they call an Eastern Data, Western Compute initiative. Here, the idea is building out much more decentralized compute clusters, so they're not trying to build gigawatt-scale compute. This compute is then being provided to many organizations rather than just one company, and it also has this additional goal of regional development. So part of the idea is that in the more developed regions in the East, you take the data from them, you send it to the West, and you build up all these data centers there, more underdeveloped, and you can use that as a way to get economic growth going. Now, that's the domestic space, but then talking about the power of empires is also, it leads us to talk about this international expansion element. And for America, the world is very clearly divided between the US and China. Those are the only two real players in the AI space for them, and you're either with the US or you are with China. And effectively, America has been leveraging its control over the most advanced technology, the most advanced AI models, the most advanced semiconductors, and going to countries and saying, if you want access to this stuff, you have to give us a bunch of things in return. I'll give a simple example, which is the UAE deal between the US and the UAE, where the UAE will get 500,000 NVIDIA chips, and in return, the UAE effectively had to kick China out of its technology stack. So lots of bilateral deals like this being made around the world. There's been threats of tariffs against Taiwan, for instance, in order to try and get TSMC to build semiconductor manufacturing in America. All these ways of leveraging and exerting force around the rest of the world. There's a really interesting, I think somewhat underreported initiative as well called the Tech Corp, which is built upon this idea of the Peace Corps. So you get young, idealistic Americans to go out to these foreign governments, and when the foreign governments are wondering, how do we introduce AI into our healthcare system, these engineers will be there to say, you should check out these products from Microsoft. This is, again, a way to expand the US AI stack. And then they've been fighting against any international regulation of AI as well. China, by contrast, has been taking a very different approach. They've been taking much more leadership of global governance efforts, supporting multilateral proposals, putting forth their own ideas for how to govern AI globally. They are effectively trying to set particular norms around AI and also set the agenda at an international level around AI. They've become the most vocal supporter and supplier of open source AI, which is one of the key ways in which they can export their Chinese AI stack around the world. And then they've also been offering support to Global South countries to build up their technological capabilities. Now, the story I just presented, though, is too simple. It's more complex in practice. And I think, and I try and go into this a lot in the book, I think the US ruling coalition is fractured in a way that it hasn't been for some time. So if you look under Obama, you sort of have this peak Silicon Valley consensus where what Silicon Valley wanted was what Washington wanted. And there was, for America at least, a beautiful harmony of interest between them. However, that has changed since then, particularly under Trump, but also under Biden. And effectively, you have multiple different tech elite groups, and you have multiple different political elite groups, all vying to push for their hegemonic vision of the future. On the one hand, for instance, you have these big tech companies like Microsoft, Amazon, and Google, who thrived in a neoliberal world. They want a neoliberal world. They don't want tariffs. They don't want export controls. They don't want geopolitical tensions. They want to be able to sell to the Chinese market and things like that. By contrast, you've got an emerging sort of techno-nationalist group, particularly around the defense tech companies, so Palantir, Anduril, Shield, these sorts of companies, and venture capital is now lining up behind them. All of them are pushing for a much more patriotic vision of American technology. They're focused on economic security. They want to, they're not interested in supply chains as trying to minimize labor costs. They're interested in supply chains that they can secure. So they want lots of reindustrialization of America. You've also got, as we saw in Anthropic and Department of Defense, you've got this sort of growing tension between private control of military AI and government control of AI, military AI. And then within the Trump administration, you've got libertarians smashing up basic research capacity within the state. You've got mega nationalists and the fascism of ICE scaring away foreign researchers. And then you've got Trump himself making quite bellicose statements to allies at the same time that he wants Europe to take up this American AI stack. He's also making Europe extremely wary about being dependent on the US AI stack. There's tensions in China as well, but I think they're much more subdued and sort of reflective of the different political system there. The AI labs want NVIDIA chips. They're very open about this. And the government doesn't want them to buy NVIDIA chips. So there's a massive conflict of interest there. There's also, I think, been a shift in the balance of power between tech elites within China. There was a tech crackdown in the early 2020s in China, but it only really hit platform companies. It didn't hit the hard tech companies like Huawei, like the semiconductor manufacturing companies, like the lithography companies or anything. So there's been a sort of pushing down of those platform companies like Alibaba and Tencent, And companies like Huawei are now these premier lights of the Chinese economy. And then I think there's also going to be sort of open concerns about how you censor something like open source AI, because it is more difficult to control this. And I think we're starting to see this as well with AI agents. There's a lot more Chinese government concern about how do you control something like an AI agent. Controlling people is one thing, but controlling an agent is quite a different thing. My final slide here, and then we'll open it up to a lovely discussion. I think there's a number of different tensions that are sort of driving things along in the world today. There's no clear outcome, but I think if we can sort of pick out these different tensions, we can start to try and figure out where things might be headed and start to sort of guess about different scenarios. One tension is about the decoupling of hemispherical stacks. So Benjamin Bratton's sort of idea about these different stacks between the US and China. And there are efforts by those countries to try and tear apart their technological stacks. However, for technical, political, and economic reasons, I don't think that's likely to happen. More likely is that we'll continue to have this sort of overlapping of technological stacks. And countries, middle powers in particular, might be able to use that to play China and the US off against each other. As I try and argue, I think there's also a struggle over the hegemonic vision of technology in the US. There's this sort of neoliberal vision of technology, digital world underpinned by American technology. And then you've got the techno-nationalist vision as like securing America's basic existence and things like that. That struggle, I think, is still very much in play. And it may turn out in a few years that neoliberalism wasn't the worst thing in the world. We may look fondly back on that era. And then I think there's going to be growing sort of struggles over this control of military AI, especially as it becomes more and more powerful. And also, I think an interesting issue is not just, say, Anthropic in the US government, that sort of struggle, but Anthropic in foreign governments. So it's notable, for instance, that Claude Mythos, this apparently very capable cybersecurity machine, was given to the US government to use and play with, but foreign governments had a sort of delayed access to that. And in the future, maybe foreign governments won't even get access to these sorts of models. So that sort of thing is, again, another tension that's emerging. No final answer, but hopefully you can try and tease out some answers in the discussion. Thank you very much.